Okay, let's go ahead and get started then. So we're going to start, like I said, with just some review here. So describe the end behavior. Okay, so we know we did this yesterday by looking at the degree. So these first two are in standard form. So the degree is just the biggest exponent. So this one's going to be degree 2. Now what's more important to us now is that that's even. We have our leading coefficient here is actually also positive 2. That's the number out front. What's more important on that one is that it's positive. So if we look back at that chart from yesterday for an even degree positive, that's going to be up to the left and up to the right. And that's it. The even degrees I always think of as like a smiley face or a frowny face based on whether it's positive or negative. The odd degrees are a little bit tougher because they're either like that or like that. But yeah. Okay. Next one here, we have degree 5, which is odd. And then the leading coefficient is actually -1, which is obviously negative. It's -1 because it's kind of a negative with no number out front, so that's an invisible 1. So if we look back at our chart from yesterday, odd degree negative is decreasing. It starts up on the left and then goes down to the right. Okay, now these next two, we have to remember, these are now in factored form. So in factored form, to find the degree, we have to add up the exponents, okay? So the degree here, I have 2 plus 1 is going to give me 3. I'm not counting anything for the 3 out for the one out front because there's no x there, okay? Now that 3 out front is our leading coefficient, so that's 3. And so that's positive, right? Okay. So if we look back at the chart from yesterday, the odd positive is kind of the opposite of the odd negative. So it starts low and then ends high, down to the left and up to the right. All right, last up on this section, number 4. So the degree on this one, we have an invisible 1 plus 2. And I do have to count this exponent of 3 there because it is an exponent of x. So 3 plus 2 plus 1 is going to give me 6. The leading coefficient here is -3, which is obviously negative. So the even negative is the last one we haven't done yet. So that's down to the left and down to the right. So now you have all 4 there on this page if we need it later, which we will. All right, next up I wanted to review describing the end behavior. So that's using those infinities. So I just want to practice this one more time because this is kind of tricky. We do have one question on our test next week that asks for this. Okay, so we first do the same thing we did before, degree. So the degree on this one's 5. And the LC is positive, so it's an odd positive. So odd positive, just like number 3, is down to the left and up to the right. So I'm actually going to write that out. So down is y negative infinity. left is x negative infinity. So just remember on this, up and down is y, down is negative y, up is positive y. And then left and right is x, left is negative x, right is positive x. So for the upright, that's going to be y positive infinity as x positive infinity as well. All right, now number 6. This one's going to be a degree 4, even. Even negative. So that's like number 4, down to the left and down to the right, even negative. So we know both of these are down, so both of our y's are going to go to negative. And then we have a left here, so that's x negative. And like I said, y is negative again for this one, as x is actually positive. Okay, now, review done. Let's learn some new stuff. We are going to sketch these polynomials, okay? So now we're going to kind of put everything together here. So check this out. We're going to start off by drawing our arrows, okay? So that's kind of the same way we were doing before. We're going to identify the degree. So this one's in factored form already. So the degree would be 3 because we're adding up the exponents there, right? 1, 2, 3. The leading coefficient would be positive. It's positive 1. So this is an odd positive. So just like we did before, when it's odd positive, we're going to draw the arrow down to the left and up to the right, okay? But now, we're going to put zeros, okay? So the zeros, or also known as roots, are going to come from each parentheses. And it's always going to be the opposite of whatever is there. So for x minus 3, we're going to put 3. For x plus 4, we're going to put negative 4. And then for x minus 1, we're going to put 1. So those are coming from the parentheses. I'm going to draw those on the x-axis here. So we'll draw it at negative 4, at positive 3, and positive 1. So now we're going to draw our graph. So we're going to start at the arrow on the far left, which in this case is going down. We're going to go through all of those x-intercepts, and we should end up on the arrow going up to the right, okay? Let's give it a try. So I'm going to start down here, go up, go down, go up. Let's take a look here at the Desmos. I'll do y equals parentheses x minus 3, x plus 4, x minus 1. Take a look here. So we start down at the bottom. It hits here at negative 4 comma 0, you can see. Comes back down at 1 comma 0, and then goes back up at 3 comma 0, and then goes forever. Now, is this kind of mountain here, is this peak higher than I drew my peak? Yeah, sure, right? But I'm not concerned about that. We're just going for like the general shape here. Do you see how they match up? Pretty sweet, right? All right. Okay, so let's try this one then. So number 8 here is going to be degree, let's see, 1, 2, 2 plus 2 is actually going to give me 4, right? Our leading coefficient here is negative 1. Notice we have that negative out front, correct? All right, so degree 4 negative, according to our chart, is down to the left and down to the right. Or even degree negative is down to the left, down to the right. So now let's look at the zeros or roots. I'm going to say negative 3. I'm going to say negative 1. And I'm going to say 2. However, 2, I'm going to call this actually a double root. Why is it a double root? Because it's squared, okay? Now that's actually significant because that's actually going to bounce. Doubles always bounce, okay? So I'll show you what that looks like. So I have negative 3, I got negative 1 or normal ones, but then positive 2 is going to be a bounce. So I'm going to start at that green arrow going left and down. I go through the x-axis and then back down. On this one though, I'm going to bounce off that one. So you can see it doesn't break through to the top half that time. And now it goes back down to the bottom. So since it came from the bottom, it bounces back down to the bottom. If that one came from the top, it would bounce back up to the top. All right, let's take a look at this one on the Desmos. All right, and see there, starting from the bottom, goes through at negative 3, comes back down at negative 1, and then bounces off at 2 and stays below the x-axis. Is it exactly the same? No. But what I'm really worried about is where is it above the x-axis versus where is it below? And that does match up on our graph. Okay, let's skip 9 and 10. Oh no, let's do number 9. That's fine. This one I'm going to say is degree 4. It's degree 4. I do have to count 1 for that x out front. It's a first power. The leading coefficient here is 1, so that's a positive. So even positive is up to the left and up to the right. Since this is degree 4, we're going to have 4 zeros. Now, I'm going to leave the first one blank. But the next 3, you should be able to see are positive 3, negative 4, and positive 6, correct? So what's the first 0? Anybody in the chat, can you guess what that first 0 is for the x out front? Nope, it's not 1. That's a good guess, but it's not, although you're close. Nope, not negative 1. Just as close there. Somewhere in between negative 1 and positive 1. 0. Yes, anytime you have this x out front, that means that x equals 0, okay? Okay, so let's draw these in here. So we got negative 4, we got 0, we got positive 3, we got 6. None of these are going to bounce because none of them are doubles. None of them have the squared. So I'll just go down here. Make a nice little W there. Definitely want a W on number 9. Don't want to take the L on number 9, right? All right. Cool. Let's go ahead and skip number 10. Let's jump down here and do number 11. Okay, so number 11 says find all roots, and it starts off by telling you that 3 is a root, okay? So, we actually did these before, okay? This is the one where we put 3 in the cupboard. And then we do our synthetic division. Remember these? So we bring this down as a 1, multiply by the cupboard, multiply by 3 going back up. Bring that down as negative 3, multiply that by the cupboard going back up. Bring that down as negative 4, multiply that by the cupboard going back up, and we get 0. We know we started off with a degree 3, right? So that means our results are degree 2. So that's going to be 1x squared minus 3x minus 4. And then if I want to find the rest of the zeros, I'm going to factor that. So we're going to think of two numbers that multiply to negative 4 and add to negative 3. So that would be, what is that? Negative 4 and positive 1, right? Do our grouping here. Second group looks like we cannot take anything out, but you have to take out either 1 or negative 1. So I'm going to take out positive 1. So now we could say x plus 1 equals 0 and x minus 4 equals 0. So we get x equals -1, x equals 4. But there's actually one more 0. It is 3. That was kind of the one that was given, but it still does count, okay? Furthermore, we got, this was a degree 3 polynomial, correct? So on a degree 3 polynomial, we should always get 3 zeros. So that's why we have to count that 3, okay? Before we go on to number 12, I want you guys to check out number 13. So what does number 13 say? It says graph number 11. So we can actually take that information from number 11 and jump down here and graph it. Okay? Now, what's the degree on number 11? Well, if you look at the standard form, the biggest exponent is 3, correct? So that's going to be an odd. The leading coefficient is just 1, so that's going to be a positive. So we have an odd positive. So that's going to go down to the left and up to the right. What are my zeros? Well, I figured them out right here in blue, correct? That was all of our synthetic division and our factoring. So I can draw these at +3, -1, and +4. So now I can just draw my graph. Let's go ahead and check out the decimals for this one. It's pretty cool. All right, so we get x to the third minus 6x squared plus 5x plus 12. And there you go. Starts at the bottom. Started from the bottom, now it's here. As Drake would say, at -1. Then it hits again at 3, and then again at 4. You can see it just goes underneath for a little bit there in between 3 and 4, right? Just like we did. Pretty sweet. Love it. This is like art, you know? It's like the closest thing I get to art. I'm like the least artistic person in the world. But I like this. I like looking at art. I just can't like create anything that's artistic, you know? Art. Yeah, for sure. I can like barely draw a circle. All right, let's do another one of those. Let me get my full screen back here. All right, let's do number 12. It's going to be a little more challenging, but stick with me here. So this one, they gave us 2 roots. So when they do that, we're going to start off the same. So we're just going to we're going to just do the first one, put it in the cupboard. All right, bring down the 1, multiply by -2, add down, multiply by -2, add down, multiply by -2, add down, multiply by -2. So then what we can do with this one, since they gave us 2, is we can actually take the second one. So I can take 1, and I can just do it to the leftovers. I can bring the leftovers down and just go for another round here. Don't go back to the original. Bring it down as the leftovers, okay? So I'll bring this down as 1, 1, 0, 0, -4, -4, and 0. So we started off here at a degree 4, correct? And I've always told you guys that whenever you do one of these, it drops it by 1 degree. So at this step, it would now be a degree 3, but we actually did it again So now this is now a degree 2. So this is going to be x squared. Technically, that's plus 0x. I'm not going to write that. I'm just going to write minus 4 equals 0. We actually can factor that more. If you remember, this is actually our difference of perfect squares. Remember, we used to do this, like x minus 2, x plus 2, right? Remember that one? So if x minus 2 equals 0, that means x equals 2 if I add that over. If x plus 2 equals 0, I subtract that over. X equals negative 2. But remember, because 1 worked, x also equals 1. And also remember, since negative 2 worked, x also equals negative 2. Wait a minute. We already have a negative 2 down there, correct? So check out what I'm going to do here. Since I have negative 2 showed up twice, this is going to turn into another one of those doubles. That's going to give me a bounce. Okay? So at negative 2, we're going to get a bounce, a double bounce. So 1 and 2 are going to be normal ones, and then negative 2 is going to be a bounce. Now, wait a minute, Mr. Berry. This was a degree 4 polynomial. Didn't you say a degree 4 polynomial should give us 4 zeros? I did, right? And so how many do we have? Well, it looks like we only have 3. But since negative 2 is a double, we count that one twice, okay? So it's like 1, 2, 3, 4, okay? All right, so let's go ahead and graph this. So we know back in the original, we were talking about it. We had a degree 4 in this case. And it was, so that's even. We had a leading coefficient that was 1, so that was positive. So even positive is up to the left and up to the right. All right, we'll draw our zeros here. So we have positive 1, positive 2, and then negative 2 is going to be our bounce. So I'm going to start from the top. Since I'm starting from the top and I hit that bounce first, it's actually going to bounce back up to the top. And then it'll drop below the x-axis at 1, and then go back above it at 2. Let's check this one out in the Desmos to see if it works. All right, so we got a big W looking thing there, just like we got. You see how it bounces there at negative 2? It never goes below right there. It does go below at positive 1. And then it goes back above at positive 2. Let me zoom in here. There you go. All right. Cool. You know what? It's Friday. Let's not worry about whatever number we skipped. What did we skip? 10. Don't worry about it.